Today we talk about another absurd yet interesting topic. This is Knowledge Simplified and you are watching Can a Star Turn into a Planet?
So let's get straight to it. Can a star turn into a planet? The answer is yes. As absurd as it sounds, it's possible. But this transformation takes place for only a specific type of star. This star is called a brown dwarf. A brown dwarf is a substellar object that has a mass between those of the heaviest gas giants and the least massive stars. That is about 75 to 80 times that of Jupiter.
Some scientists do not consider brown dwarfs to be true stars. This is because they do not have enough mass to ignite the nuclear fusion of ordinary hydrogen like a normal star. At the same time, some scientists do not consider brown dwarfs to be true planets. This is because they typically sit at the center of a solar system, just like a star.
Before we get into the discussion about brown dwarfs, let's learn the difference between a star and a planet. Stars form from the collapse of gas and dust in the primordial cloud. Consequently, they have a relatively low number of what astronomers call metals. To astronomers, metallicity refers to any element heavier than hydrogen and helium. Stars usually travel on their own or as part of a loose group of similar objects. They are massive enough to spark hydrogen fusion in their cores.
Planets form by accumulating leftovers in the primordial cloud. After the star has collected up the majority of gases, planets form with much less mass than stars and thus have much weaker gravity. The lighter elements like hydrogen and helium, which are very common in stars, tend to escape a planet's weaker gravitational pull. Thus, planets have much higher metal content. Planets typically orbit stars. By astronomers' most recent definition of the word planet, they clear their own orbit of debris.
Now that we know the difference between a planet and a star, let's talk more about a brown dwarf. An atom of heavy hydrogen is just like an atom of regular hydrogen, except that it has a neutron in its nucleus in addition to its proton. This extra particle in the nucleus makes it heavier. This neutron also acts like additional nuclear glue, making it easier to fuse together two atoms of heavy hydrogen. Additionally, heavy hydrogen is much rarer in the universe and in stars than regular hydrogen. Therefore, a brown dwarf cannot burn its regular hydrogen and quickly burns up its heavy hydrogen because there is so little of it.
As a result, a brown dwarf stops emitting light and heat early in its life. It then steadily cools and dims until it behaves more like a planet, such as Jupiter. Despite the fact that a typical brown dwarf remains positioned at the center of a solar system, just like a regular star by the way, it spends the rest of its life looking and acting like a planet. In such a solar system, the end result is a collection of planets orbiting a large central planet with no star to be found anywhere. Such a solar system ends up very cold and dark. This is the reason why it is considered as a planet and a star too.
As of 2018, over 3,000 different brown dwarfs have been identified by telescopes. This does not mean that brown dwarfs are rare, it just means that brown dwarfs are hard to detect. This makes sense when you remember that through most of its life, a brown dwarf is dark like a planet. A recent statistical analysis estimates that there are about as many brown dwarfs in our galaxy as there are regular stars.
This was all from our side. We hope you learned something new in this video. If you like our content, consider subscribing. It really helps us out and you can always change your mind. Alright then, we'll see you next time.